Welcome back. So, it may be a few days since you've done some work, or if you're just catching up, you're kind of right in the midst of it. And today we're working on currents and the air temperature. We are in Unit 6, Chapter 2, Lesson 3. Now, the reason why I want to bring this up is because we're moving past some of the big concepts, and I want you to really understand and bring it back to the first chapter. So in the first chapter, we were introduced to this problem with El Nino. And let me just exit out of the slide. We were introduced to El Nino, and we were introduced to different claims that we can try to understand what's going on inside of this area. So if we go to the questions here, we have during the El Nino years, why is Christchurch, New Zealand air temperatures cooler than usual? So far, we've eliminated claim 1. The amount of incoming energy does not change during this time period. And we learned that from the graph where it showed us that Christchurch was receiving the same amount of sun during and not during El Nino years. That leaves us with claims 2 and 3. And claim 2 says something about the Earth's surface, land, or water changes. And claim 3 says something about the air changes. So right now we're working on determining if 2 or 3 are correct or incorrect, or if there's a combination of the both like we've seen in the last unit to understand this. So to go back to our current lesson, we are on Unit 6, Chapter 2, Lesson 3. And right here in the warm-up section, it says, trash from all around the world, especially plastics, pollutants, pollutes the ocean. There are areas in the ocean that have much more trash than other areas. For example, the Great Pacific Garbage Patch is a huge mass of tiny pieces of garbage circulating in the Pacific. Now, I know you've heard about all the problems with throwing garbage on the floor and our garbage in our oceans and save the turtles and all of these problems going on with garbage in our ocean. But now we have to kind of figure out why certain places in the ocean may actually have more garbage than others. And it says the questions that you have during your warm-up are based on what you learned about currents. How do you think the mass of trash ends up in the Great Pacific Garbage Patch? And then, after you answer that question, look at the map and what ideas do you have about why the trash is trapped in this location? Now, you're going to answer these questions. Let me just get to the right chapter because I did switch over. We're in Chapter 2, Lesson 3, and in the warm-up here for you guys. Now, you're going to reply to both of these questions right here, and at this time, press pause to answer the questions and then come back to hear my responses to these questions. All right, welcome back. So, based on what you learned about currents, how do you think the mass of trash ends up in the Great Pacific Garbage Patch? Well, if we look at them, it's coming right off the coast of all of these countries, and it's getting pushed right here and then spun around. And it kind of gets pushed in by multiple currents. So I would write multiple currents are being pushed into this area, They get stuck because the current is a constant circle. So it's not exactly a circle, but the idea is the same. The idea that it gets pushed in and it constantly goes around and around and around. This area is almost, it's like a never-ending almost, it gets stuck there because it never ends. You might have a vocabulary word. I'm not going to tell you the answer with which vocabulary word you should be using, because I'm going to be testing to see how well your knowledge is about the vocabulary. And when we say trapped, I kind of answered it up here, and I could kind of bring this part down here. So I'm going to copy, paste. At this time, you might want to press pause so you can get some of these answers, and you want to add more to both of these parts. All right, I'm going to move on to the next activity. And the next activity is actually an experiment. But I want to bring it back to what we're going on here. So the last lesson, we introduced Buenos Aires, which is in Brazil, and Cape Town in the southern part of Africa. So how does the currents affect the air temperature of Buenos Aires and Cape Town? Claim one is that the currents in near each city will cause the Buenos Aires temperature to be the same. And the other is that it will choose for it to be different. Now, based on what we learned from the maps of these two towns, we learned that Buenos Aires has a lot of warm water coming in from the equator, and Cape Town has a lot of cold water coming in from the polar regions. So we know that claim 2 is correct. We've kind of discussed this in the last video, that the bottom part of the polar is going to bring the cold air up and the hot air down. What I'm going to show you today in the experiment is how this actually show you that it actually works. So I'm going to take 2 cups today and pour one with hot water and the other with cold water. And I'm going to test the air temperature around the water of each of these cups. So stay tuned for the experiment. Okay, so welcome to the experiment part of this. And what we have here is 2 cups of water with the same exact amount of water in it. And this would act like if these 2 bodies of water were on the same latitude, meaning they're on the same line. I already took the temperature for them as for the air above them. And you'll see the data table in the video, so don't worry about taking notes right now. I just want to show you guys what happens. So these 2 areas of water are going to have 2 different bodies of water introduced to them. We have body number 1. Sorry, I'll start with body number 1 because on your graph it's this one. This is hot water. I've microwaved it to a boiling point. And what I'm going to do is I'm going to pour the water to the green line. Then I'm going to take ice water and follow the same idea. So now I filled one with hot water to the green line and one with cold water to the green line. I'm going to put lids on them just so I can test just the air above it, not necessarily the air surrounding it. And then I'm going to take, so I've covered them, and then I'm going to take thermometers and I'm going to test the air above it. It's going to take about 2 minutes to get the air above it. But essentially this is the basics of the experiment. We want to know what happens to the air right above water or body of water when we add hot to it, and what happens to a body of water when we add cold to it. When we get back to the slides, I'm going to go over the data of which I got for these experiments, and we're going to discuss why this is important for understanding what might happen during the El Nino years for Christchurch, New Zealand, and to compare the temperatures of Cape Town and Buenos Aires. See you guys in a minute. All right, everyone, welcome back. So, like I said in the experiment, I'm going to give you guys the data points now for you to fill in. So at this point, you should be going back to your Amplify a website, and here we have the data that I that I got. So when I tested the air temperature prior to the whole mixing of different waters, I had 19.5 for both the hot and cold water cup, which makes sense because they both started at the same temperature. And then when I mixed in the hot water, it raised the air temperature above the hot water 20 to 23.3 degrees. And then when I added to the cold water, when I added cold water to the cup, it went down to 14.5 degrees. Both of this makes sense as we are continuing our investigation about how currents play a role in how air temperature could change. So essentially what we have here is the question says, explain why the air temperature in each cup changed. What must have happened to the energy in each cup? For cup 1, the air temperature increased, which means the energy increased. The energy from the hot water spread to the water that was in the cup and to the air above it. So the heat from the hot water spread from the water to the air, making the things around it hotter. For cup 2, the air temperature decreased, which means the energy decreased. The energy from the water that was in the cup was spread to the water that was added. So the warm water, the room temperature water, the heat from that water went into the cold water, and also the heat from the air is going towards the cold water, melting or getting the cold water to get warmer, which means it's taking some of the heat away from the air, making it cooler. Now, if you want to pause to copy this answer, this will be a good time. If you're done, please click on Next Activity. All right. Now, as we move on to the next activity, I already did the experiment, but I'm going to open up the simulator. And what it's asking us is to compare two areas that have different currents spreading into it, which is similar to the Cape Town and Buenos Aires areas, right? They're on the same latitude, which sensor 4 and sensor 5 are on the same latitude, meaning that we would believe in normal circumstances that they would be the same temperature. But as we view the surface temperature during this, I'm going to speed up the process a little bit to ×2. We notice that area 5 is getting warm water, which is raising the temperature. Whereas area 4 is getting cooler water coming down, which is not allowing the temperature to rise as much. But then also let's pay attention to these two areas right here. We notice that here the energy from the air is going to the water, meaning that the air was hot and it's pushing towards the water, which is now cold. Because the cold water is coming in, the hot air is pushing towards the water, cooling off the air. Whereas in this area, the hot water is coming here and the heat from the water is going into the air, making this rise to a higher temperature. Here we have 19.9 and 24.2. So in basic, heat has to go from the hot to the cold. So if the air is hotter, then it's going to heat up the water. If the water is hotter, it's going to heat up the air. In this case, the hot water is coming up, heating up the air. Here, the cold water is coming in, and the air is heating up the water as it comes down. Now, we know that air gets its temperature from the land, but remember that the sun is heating up over here and kind of pushing the air this way. So it's a bigger air mass than we're talking about. But in general basic principles, this is getting cold water, so the cold water and the air is warming up the water. This is getting hot water, so the water is heating up the air. Not that it's heating it up, it's transferring energy. This air was already hot because of the sun. The surface over here was hot, and this air over here was hot. Then the cold water came, and the heat started going into the water. This area was hot, but got even hotter water, so the heat from the water pushes up. So now let's go back to our slides. If I can get to it. There we go. Energy transfers from warmer to colder, and we know this from our previous units. So warmer currents transfer energy to the cooler air, and the warmer air transfers energy to the cooler currents. And to continue that idea, when an ocean current comes from the equator, it brings warmer than expected water to places it passes, and that water is warmer than the nearby area. When the ocean current comes from a pole, it brings colder than expected water to the places it passes, and that water is colder than the air nearby. So, like I've mentioned in some of my online, like the live videos, this mostly impacts coastal areas. If we were to put this on 3, which is not necessarily very coastal, you'll notice that they don't really have much of a change because their air is not really being affected by the ocean, whereas these are on coastal. So that's a very important part to remember when we talk about air moving, is that it's mostly affecting coastal areas than it is areas that don't involve water. Now let's go back to our lesson here. I wrote down the numbers for my previous experiment. So sensor 4, that's obnoxious. Let's get back to it. Perfect. Sorry about that. Sensor 4, both sensor 4 and 5 started at 17.2. And the final air temperature, sensor 4, which was getting the cold current, is 19.9, whereas sensor 5, which was getting the warm current, was 24.1. So when there's warmer water coming in, it's going to heat up the air much more. And so over here, we have the last final questions that I'm going to be grading. And one says, at which location does energy transfer from water to air? At sensor 5, where it's getting the warm water, it gets the warm water comes, and that warmness transfers to the air. And then part 2 says, at which location does energy transfer from the air to the water? That's what happened at sensor 4. So the air around sensor 4 was warm because of its location on the equator, but then the cold water underneath it starts to come in, and that air has to warm up that water, continue to warm up that water, so it loses some of its heat when making it a colder place. Why is the temperature shown at sensor 4 different from sensor 5, even though they're at the same latitude? And here, again, you can pause to copy. They are receiving different temperature currents. Area 4 has a cold current, making the water colder, so the air is warming up the water. At area 5, the current is warm, so that water is warming up the air. Make sure you click on this button that says Next Activity. I am not grading this page, so this is where I'm going to end the video. If you have any questions, make sure you bring them to our live sessions, and I'll talk to you guys soon.